Hey, so I wanted to spend a couple minutes and just talk about Lewis dot structures and molecular geometry. So basically what a Lewis dot structure does is it's a diagram that shows valence electrons. And if you think about it, within an energy level, on the valence shell, you're looking at the s and then the three p orbitals, px, py, and pz. And each of them can hold up to 2 electrons. So what you can do is around the symbol for an element, put kind of 4 places for orbitals that can fill up to 2 electrons in each of the orbitals. So for example, if you had magnesium and then carbon and then nitrogen, magnesium, when you look at the periodic table, is an alkaline earth metal, and it has 2 valence electrons. So you could put a single dot on either side. Carbon is basically 2p2, so it has the 2s electrons and the 2p electrons, so there are 4 valence electrons, and you could put a dot on each side. Nitrogen is 1 over, so it has 5 valence electrons, so it will have a full orbital plus 3 orbitals with just a single dot. Now, if you were to look at the diagrams of them, they look like this. So magnesium would have 2 dots and, with 2 valence electrons. Carbon, again, 4 dots, 4 valence electrons, and nitrogen, 5 dots with this orbital full and those all needing 1 electron. Now what this does is then kind of shows you what these substances how they can bond. So magnesium essentially has 2 places to attach to. Carbon has 4, which makes it such a good molecule um, for structure of molecules within the human body. Nitrogen also really good for things like proteins and a lot of the compounds in your body, because it has 3 places to attach other elements to. And again, each side would represent an orbital, so you can have 4 orbitals, the s orbital, and then px, py, pz. Now, you can kind of look systematically across the table, where the first column there, the alkali metals, have a single valence electron. The second, the earth metals, have 2 valence electrons. When we go to the column with aluminum, 3 valence electrons. Carbon's column 4, nitrogen's 5, oxygen 6, fluorine 7, and the noble gases are full, which means the noble gases can't really, there's nowhere to attach to them. So they have a difficult time bonding to other things. Whereas the halogens here always have one spot where it is, very easy to attach. So you'll often see the halogens attaching to other molecules. Oxygen has 2 places, so like H2O, there are 2 things bonded to it. And essentially, when you use Lewis dot, you can use that as a tool to figure out how molecules bond together, and essentially draw each element and determine the central atom. So like H2O, O would be the central atom. Rearrange the dots so the atom achieves the octet rule. And you try to pair up electrons and use lines then to represent a bond. So a line represents 2 electrons. And so these are some that you could do. And this is just showing a few of them. So if you have 2 chlorines, Cl2, coming together, chlorine has 7 valence electrons. So it will bond, they'll share 1 electron each, and you'll get, Cl2, with each one then having 8 electrons around it, since they're sharing the 2. With phosphorus tribromide, phosphorus again has 5 valence electrons, bromine 7. So phosphorus has 3 places to bond and bromine 1. So a bromine will slip into each of those 3 places. With H2TE, Te is kind of like it's in the column with sulfur. It has 6 valence electrons. So with 6 valence electrons there, hydrogen has 1 valence electron. So again, you'll get 2 hydrogens attaching to Te. And so that just is a quick look into Lewis dot structures.